Okay, so good morning once again. So these are the two questions raised by the class. The first one is, what's the difference between morphology and part of speech tagging? And the second one is, how can we prepare a corpus for local language? For the first case, they are quite different. If you remember the definition that we have given for morphology, we said morphology is concerned about parts of a word and their meaning or their function. Okay, this is what we mean by morphology. Okay, for the first case, morphology means it is concerned about. By the way, even the name itself, morphology, is concerned about parts. Even for other sciences, it is concerned about parts of something. So in this case, morphology is concerned about part of a word and their meaning. For instance, if you have, let's take an example. If you have words like, let's say, unclear, okay? This is a single word. Now, to analyze this word or to understand this word, what we need to do is to look into the parts. And when you do that analysis, it shows you that this word is a combination of the morpheme an and another morpheme, which is clear. And if you see these two, the second one, which is clear, okay, let's take the second one. The second one has a dictionary meaning, okay? It has a dictionary meaning. If you go to the dictionary, then you'll understand what the word clear means. And this word cannot be further divided into smaller pieces. And if you see the first part, in English, this is what we call a negative marking morpheme. Okay, it's a morpheme, and the purpose is a negative marker. Okay, so this is what we mean by, in a very short example, this is what we mean by morphology. So morphology is concerned about parts of a word and their meaning. So in the first case, we said an is part of the word. You see, there is a word unclear. An is part of the word, but it has a function. The function is to make a word to be negative. And clear is also part of the word. But unlike an, it has a dictionary meaning. If you go to the dictionary, you'll get a meaning. There is a lexical meaning associated to this one. So analyzing words in such a way is what we call morphology. And the same is true for Amharic, for example. If you take the word, let's say al-sabaram, okay? If you have al-sabarum, let's take this one. If you take this word, it appears to be a single string, but if you do the morphological analysis of this word, it would be a combination of al, then sabbar, then ku, then min. So what we call morphology is to make analysis of this part of the word. As you can see, these are parts of the word. So what we're going to do is try to have a meaning to each part of them. So from this one, we know that the word sabbar has a dictionary meaning. This one has a dictionary meaning, because if you go to the Amharic dictionary, you'll understand that the word sabbar is the act of breaking. And again, if you see the other part, which is ku, this is not a dictionary meaning, rather than it is a linguistic function. This is what we call is morphological analysis. And this, when it comes to the Amharic morphology, is the marker for first person, singular subject with neutral gender or no gender, okay? Because it doesn't show whether the subject is male or female, okay? This is what it shows. And the other part of, again, the same word, which is, if you take these parts, al and me, in combination, these are negative markers, okay? So as you can see, making such kind of analysis to a word, you see, the word is al-tasabbarkum, but we divided it into 4 parts, and these parts have their own contribution to the meaning of the word. The word sabbar has a dictionary meaning. The word, the morpheme ku is a negative marker, I mean, a marker for first person singular neutral gender or neuter, then al and m in combination is a negative marker for the Amharic word. So making such kind of analysis of words is what we call morphology. Okay, morphology is concerned about identifying part of the words, and after identifying the part of word, to give it either a dictionary meaning or to identify the linguistic function or the morphological function of those parts. As you can see, the word clear has a dictionary meaning, the word sabar has a dictionary meaning, but the morpheme an has the function of making words to be negative. The morpheme ku has a function of showing that the subject is first person singular neuter, and the morpheme al and m from both sides are negative marker for Amharic. So doing such kind of analysis is what we call morphology. In the other case, if you see part of speech tagging, okay, part of speech tagging is the action of, this is assigning the word class for words in a sentence, okay? In a sentence, whenever you assign the word class for every word, that's what we call is part of speech tagging. So for instance, if you have words like, the small boy came, let's say, or likes the girl, okay? If you have this sentence, as you can see, there are many words, and each word belongs to some class. So for example, as we said last time, the is a determinant, small is an adjective, boy is a noun, like is a verb, the is again a determinant, girl is a noun. Now, giving each word the part of speech they belong to is what we call part of speech tagging. And part of speech tagging might sometimes be difficult, as we said earlier. What if I have the word, the one that we see last time, if we say the boy saw the saw, as you can see, we have the same word saw, but in the first case, we know that there is a determinant, boy is a noun. In this case, saw is a verb. Here we have a determinant. The last saw is a noun. I mean, sorry, no, the second one, yeah. So as you can see, even though it has the same spelling, we know that in one of its place, it's acting as a verb. In the other place, it's acting as a noun. And there are many such kind of words, that needs disambiguation or that needs identifying the correct part of speech for a word in a sentence. So as you can see, the two concepts are quite different. Morphology is concerned about analyzing a single word and the part that it has, whereas part of speech tagging works at a sentence level. Mind you, part of speech tagging for a single word is not going to be meaningful as such, because if you find the word, for example, book, what do you do? What is a part of speech of book? What is a part of speech of book? Anyone? David?
Noun.
It's noun, right? But it can also be a verb, because I can say, please book my flight. I don't know. So in this case, it's acting as a verb. So at a sentence level, a word can have many parts of speech, or it can belong to many parts of speech. But whenever you use it in a sentence, at that specific context, it's going to have only one part of speech. And working on that one is what we call part of speech tagging, which we are going to see in chapter 3, okay? And coming to the second one, is that clear?
Yes.
Okay. If that's clear, coming to the second question, how are we going to prepare corpus for a local language? The question is, for what kind of application? Can you give me an example? For what kind of NLP application are you concerned to prepare a corpus? Because for many different kind of NLP applications, the way you prepare a corpus would be quite different. So can you give me one example? For what kind of application do you need the corpus for?
For grammar checking. For grammar checking.
Okay, if it is for a grammar checker, grammar is concerned about, okay, grammar is concerned about word order and grouping. We know this, right? Grammar is concerned about word order and the grouping of words. That's what we call is a parsing. By the way, we have a chapter on this one. I'm just giving you, a very brief description, but we know that in chapter 3, we're going to talk more about those things. Now, in this case, whenever you want to learn word order and grouping, what you need to have is you need to have a corpus where, so the corpus is going to be, if you have to develop a corpus for a machine learning algorithm, what you're going to have is a collection of tagged sentence. Okay, the tag is going to be post tag, part of speech tagged sentence. So maybe you can develop, let's say, 10,000 sentence. Okay, you're going to have 10,000 sentence, but each of these sentence should be tagged with a part of speech. Now, if you tag a sentence with a part of speech like this one, for instance, we say the boy likes the girl. Okay, if you have this sentence, the part of speech tag would be like this. This is a determinant. This is a noun. Sorry, this is a noun. And this is a verb. And this is a determinant. And this is a noun. Now, you're going to have many of such kind of sentences, which means all the 10,000 sentences that you have is going to be represented in such a way. And this one will help the machine to learn this pattern. It will have this pattern, like it will say, determinant can be followed by a noun is one knowledge. Maybe noun followed by a verb would be another knowledge that it's going to develop. Or it will say noun followed by a verb followed by a noun is another knowledge. Mind you, what does this show you? One, it shows you the order of words. Like any determinant can be followed by a noun is a knowledge. It shows you how words are going to be ordered. Or it will tell you that a noun can be followed by a verb, and that verb can be followed by a noun. So as you can see, it tells you how words are going to be ordered. Not only about order, but also it tells you about the grouping. For instance, from this sentence, it tells you that you can have all these type of grouping. You can have a grouping of determinant with a noun with a verb, noun verb with a noun. All this knowledge can be captured from such kind of a sentence. So a corpus for the part of speech tagging that you can use for the purpose of grammar checking would be of such a form. But mind you, whenever you develop a corpus, the corpus size should be as big as possible, because it's only when you have many of such kind of a data that the machine learning algorithm can identify a pattern. Okay? Is that clear, David?
Yes.
Okay. Do you have any other question? Any other question? Otherwise, we have to move to today's lecture. Okay, so it means there is no question. Let's move on to today's lecture then. Now, yesterday, if you recall, we talked about the different kind of methods and resources that we use for natural language processing applications. So we have mentioned about generic computer science methods like data structure, storage mechanism, programming language. We are going to use the concept of software engineering, in all this process. And we also have specialized algorithms that are, specifically developed for natural language processing applications like parsing, generation, translation, morphological analysis, syntax analysis, or parsing, or finite state transducers. These are kind of algorithms that are specifically developed for natural language processing. We also use non-discrete mathematics like statistical techniques, especially whenever we deal with a machine learning approach to extract patterns or new knowledge from a huge collection of corpus. Then we dwell more on a statistical approach. We also say we use logic and linguistic formalism, especially when it comes to semantics or the representation of meaning. Then logic is more appropriate than the other type of formalism. So we use logical and linguistic formalisms for the purpose of representing very complex knowledge in linguistic construct. We also say that some of the resources that we use for NLP are linguistic knowledge. Mind you, we are developing a tool or a system for linguistic element representation and analysis. So some of the knowledge that we already have in that domain should be well understood and used. So for instance, if you see dictionaries, if you see rules of grammars or rules of semantic representation or rules of pronunciation and intonation, they are going to be all used for the purpose of developing natural language processing. Like the rule of pronunciation, you don't get it from anywhere else except from the linguistic knowledge of that specific language. For instance, if you see for the English language, if you write it in such a way, how do you pronounce it? You pronounce it as no. And this word also is pronounced as no. And this is going to happen only because of the linguistic knowledge that we have, or the pronunciation knowledge that we have in that language. So knowing or having the knowledge of those linguistic knowledge is very important for natural language processing. And finally, we said Corpus, especially whenever you want to develop a system using a machine learning approach, using the mechanism of extracting new knowledge from a huge collection of past data, we develop a corpora or a corpus tool for the purpose of acquiring knowledge from the domain. So we have talked about each and every one of these yesterday. Now today's topic is going to be the approach that we use to develop a natural language application. And as I said last time, we have two major categories. The first one is, we call it rule-based, or sometimes more specifically, we call it handcrafted rules. And the idea in handcrafted rules is the developer need to have a knowledge of all elements in that specific domain. For instance, if you want to develop a morphological analyzer for a language, then you have to know how all the words are created. You have to understand how what kind of attachments are going to be put before and after or inside a word. So, and not only what kind of morphemes would be attached, but at the same time, you have to know the meaning of each of those morphemes. So in a rule-based or in a handcrafted rule, it's just like the conventional programming. Like if you are supposed to develop a program, let's say, which is going to identify whether something is a palindrome or not, what do you need? You have to know what a palindrome is. You have to know how to check it. You have to know how to validate. So all the knowledge should be known prior to developing the application. Okay, in a rule-based system, that's what's happening. Like, how do you know, or if you are going to write a program that tells you whether a number is prime or not, then you are required to know, how to identify a prime number. There is no any other mechanism. So you have to come up with your own algorithm, which means all the rules should be well known. So a rule-based approach or a handcrafted rule will develop rules to process natural language based on known facts. You see, it is based on known facts and exceptions, because in a language, everything is not governed by the rule. There are some exceptions. For instance, in English, how do you make a word to be in a plural form? Gamechu. 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 Okay. Gamechu. Gamechu.
Yes.
No, I can't hear you. You have to unmute your mic. How do you know a word is a plural in English? Gamacho, I can't hear you. Okay, let's move on then. Bashir. Bashir. Bashir.
That means when we can add, for example, let's say, just like that to EIS.
Okay.
Or if some forms of verbs are added on the root word.
IES, no, just tell me the rule. Don't simply say some type of words. I'm asking you the rules. So maybe adding IES, Lelas.
Or that means in the root word, if some words are already added. Some letters.
Give me a specific.
Exceptional letters are added.
No, don't simply make it abstract. Just tell me the rules.
For example, for program instead of for boys, we can IS. The root word should be boy.
Okay, just a moment. Where is the noise coming from? From whose mic is the noise coming from? Okay, you can proceed now, Bashir.
No, already because some people are there for that reason. Just there is some voice are.
Okay, forget about English. What language do you speak fluently?
ለምሳሌ እዚህ ጋር የተለያየ ወርዶች ሩት ወርድ ላይ ተጨመሩ ለዛኛ ነው
Bashir, the noise is coming from your side. Okay. Your attention. If you are in a place where there is noise, then that's not a proper way to attend a class, Bashir. This is not acceptable. Since it's a class, you have to be in a quiet place so that I can ask questions and you can also answer the questions. Okay, this will not be acceptable at all. Okay, you have to have a class discipline just like we have it in a face-to-face. Okay, so for instance, in a language, let's say in Amharic, you might come up with some kind of rule. For instance, you'll say to make a word to be plural, you can say we can add, for example, watch at the end, or you can say we can add och, you know, if it's possible. Sometimes some words are already plural, which you're not supposed to add anything to it if you are concerned about it now. So you have to know when watch is going to be applied. You have to know when och would be applied. And if you know this rule, then based on the analysis of the word, you can say this is the end of the word, or you can say whenever the word ends with such kind of a pattern, add och. Whenever it ends with such kind of a pattern, you have to add watch. And knowing all these things is very important. So if you don't know this, for instance, if you don't know the och pattern, then you are going to make a mistake. That's why we say in a rule-based or in a handcrafted rule, you have to develop the rule based on known facts and exceptions. So what we call exceptions, for instance, in English, whenever you have the word, let's say, sheep, the plural as well as the singular is the same. So you're not supposed to add s just like other words, because the plural as well as the singular is the same. If you take the word cut, the past tense as well as the present tense is the same. So you're not supposed to say cutted or anything to this one. So knowing the exceptions is also very important. So if you don't know those knowledge, or if you don't have this knowledge, then you're going to make a mistake. So as we said, in a rule crafting, the power relies on how much knowledge, you see, how much knowledge is a researcher or the developer have. If you don't have the knowledge, then your rule is not going to be, the coverage of the rule is going to be very, very shallow, or it will be very narrow. So that's what we call is a rule-based system. A rule-based system is very efficient, but as long as you know the rules. If you know the facts, if you know the exception, then it's going to be a very efficient system. The other approach that we have, which is the state of the art, or which most of the researchers are dwelling more these days, is a machine learning approach. So the machine learning approach, what it does is, instead of depending on the knowledge of the developer or the researcher, it depends on past data, it depends on past experience, which means it tries to capture rules from examples. You see, what we call examples are past data. And this is what we call is a corpus, past examples. For instance, you are going to give the system words that are in a plural form. And from that list of words, your algorithm can identify what kind of patterns they have in common. And that common pattern would be used to develop the rule of, converting a word into, let's say, a plural form, a past tense form, or whatever. So from the examples, you'll capture the rules, and those rules are going to be applied to new instances. And a machine learning approach, I believe from your machine learning course, it can be supervised or unsupervised. If it is supervised, then during the learning process, you are going to give the example as well as the expected output. It means in a way you are dictating how the learning goes. You are supervising, you are helping the machine to learn more. In the case of unsupervised, we call it a blind learning, because instead of guiding what the output is going to be, you are trying to create some kind of clusters based on their similarity. But we don't know what that similarity is. The machine can identify some kind of pattern that are common for some of the data elements and group them together. And from that grouping, you are going to derive more knowledge. So the approach based on these, the approach that we have for NLP can be of many types. You can have finite state machine, you can have formal rule systems, especially whenever you think about a rule-based approach. You can use logic specifically for semantic analysis. We can also have probabilistic method as well as machine learning tools can be used in here. And most of the time we use, a finite state search space as well as dynamic programming are the most common two models that we are using. Now let's go, one by one for each of these. The first one is a finite state machine. Now, a finite state machine, most of the time is used for a rule-based approach, or it's a rule-based approach. And a state machine, if you had any experience on this one, it's a formal model that consists of three important things. It contains a state, it contains a transition. A transition means a transition from one state to the other, and it's going to have an input to be analyzed. So whenever you have an input string, that input string is going to go through the state, through the transition until it reaches the endpoint. So these three elements are very important. And this finite state model can be deterministic or non-deterministic, depending on what the output is going to be for a single input. For a single input, if you are going to get the same type of output every time, then we call that a deterministic finite state model. And if it has some kind of probabilistic or uncertainty, then you can also have a non-deterministic or a random kind of choice. Whenever you start a model, if there are some random modeling, then you're going to have a non-deterministic finite state model. The difference is in deterministic model, if you give it the same input, every time it's going to give you the same output. But in an undeterministic finite state model, then for the same input, you might have different outputs since it uses some kind of random method in the process. So again, the same finite state model can have a probabilistic component in it, especially whenever you use it in a hidden Markov model, which we are going to use or see during part of speech tagging in chapter 3. Now, this is a very simple example of a finite state model. Have a look at this finite state model. As you can see, it has states, okay? The circles are the states and the arcs are the transition. And whenever you have such kind of a finite state model, then you are going to have an input string. And this input string is going to go through this finite state model, and we try to arrive at the final state. So every finite state transducer will have a starting point, and it's going to have an ending point. And any input is said to be valid if it starts from the start symbol, and if it ends with the final state where everything is covered. Everything in the input string should be covered, plus it should start from the initial state and it should arrive at the final state. So we know that using a finite state model, we can generate a language. At the same time, we can also analyze a language. Both analysis and generation of a language can be done using a finite state model. Now, let's simply take this as an example, okay? Now in here, what do you see? What do you see in this finite state model? What do you see? What do you see? What do you see? What do you see in here? Huh? Is that never?
from this, I can see in a finite state, we have 3 elements.
Yeah.
We have 3 elements. The first one is state initial state, and we have to use the state initial state, and we translate. The translate one is the second one state.
Okay.
And you can see the
Okay.
input.
Okay. Can you give me a word that can be generated from this finite state model? Give me a word.
Okay. Calm.
Hmm?
Calm.
Calm.
Calm. Yeah, it is possible.
Calm.
Yeah.
How is that processed in here? Where do you find the string C? Where is the string C?
Sound.
Yeah?
Use phonics.
No, I'm not talking about phonetics. I gave you the finite state model, and I want you to give me a word from this finite state model.
Each word must be read. Oh no, each alphabet must be read.
No. I don't think you get my point, Zanabel. The question I have for you is, from this finite state model, which is displayed, give me a word. From this finite state model that's displayed.
Talk.
Yeah?
Talk.
Okay.
Talk.
T-A-L-K. Right? Now let's see how this word is processed in here. Okay, that's a correct one. So always it has to start from the initial state. And from the initial state, as you can see, I have only 2 options. Either I can go to T or I can go to W. This is my only option. And as you can see, the first word that is given in the input is T. So it's a valid one. Then after T, where do we go? As you can see, the path leads me only to A. And A is the second word in the input, so which is correct. Then from A, it leads me only to L in the third state. And the word that I have is L as well in here. Then from L, it leads me to K. And as you can see, the letter K is also available in here. So the path that I'm following will be this one. Then after that, we know that it has to end into the final state. You see, it has to reach to the final state. But from K, I have 4 different paths. Which path shall I take? From the 4 paths, which one shall I take?
I think the center one is more efficient.
No, the center one has ing in it. But the word does not have ing here. The second one has s to it. The last one has ed to it.
First.
So it is the first one.
Yeah.
And the first one tells you that if you have the word talk, it says it is the base form, the base word ማለት ነው. The others, this is a third person singular, this is a progressive form, this is a past tense form. You see, the past tense form, for example, is going to have